So for the first FRQ, you ask for the area of region S. So it's area under F minus area under G. So area under F is given 12.142 minus the antiderivative from 0 to 4 of area under G, which is 6.938, which you get 5.204. And then for the second one, which is the volume, the equation for that is pi integral of outer squared minus inner squared. So 15 minus gx squared minus 5 minus fx squared dx. That's the I just asked for the equation. And then for the third one, ask for the volume. So it's integral 0 to 4, this part negative 4 minus x gx is given, so you plug that in and you get 17.243. For the second FRQ for BC, it asks you to find the limit as x goes to infinity of x e to the negative 2x, and you simplify that, which is x to over e to 2x. As it goes into infinity, this increases, so this goes to 0. For part B, it asks for the maximum value of f for x is greater than 0. So f prime x equals e to the negative 2x, which is the derivative of this, and then plus x negative 2e to the negative 2x, which equals e to the negative 2x, parentheses 1 minus 2x. And then if the derivative of x equals 0, x equals 1/2. So 1/2 plugs back in, and then you get, so it plugs back into the 1/2 e to the negative 2 to the 1/2, which equals 1 over 2 to the e. So for part C, it tells you to evaluate integral 0 to infinity fx dx. And then so u equals x, du equals dx, dv equals e to the negative 2x, v equals negative 1/2 e to the negative 2x. So first, you get the integral 0 to be x e to the negative 2x dx. That simplifies to negative x over 2 e to the 2x plus the integral of 0 to b 1/2 e negative 2x dx, which this all simplifies to negative e to the negative 2x, parentheses x over 2 plus 1/4. And after that, you have to, it's integral 0 to infinity x e to the negative 2x dx, which then equals to limit of b goes to infinity 0 to b x e to the negative 2x dx, which that simplifies to the limit of b goes to infinity negative e to 2x, parentheses x over 2 plus 1/4. And you plug in b and 0, and the final answer is 1/4.